Alright everyone, today we're going to look at a short video of how to work a z-test with means. So let's go ahead and let's get started. So let's go ahead, let's read through the problem and let's go through all of our steps. Alright, as you recall, our first step in our process to solving hypothesis test is always going to be to read the problem and find all of our relevant information. So let's do that. Remember, we're looking for things like, is the hypothesis going to be a research hypothesis? Are we dealing with a test of means? What is our population average? What's our population standard deviation? What's our sample size? And what is our sample mean? We're also going to be looking for things like the claim that we're testing for and stuff like that. So let's read through this problem. The manager of an insurance company wishes to conduct a study. Okay, we've just seen our first buzzword that we're always looking for. That study right here. So what that's going to tell us is, this is a research hypothesis. We're doing a research hypothesis. So if the manager of an insurance company wishes to conduct a study to see if the current rates charged to customers are sufficient to cover the claims by the insurer. If the manager sees that the claims paid by the company have increased, she will have to raise the rates to ensure that the company stays solvent. So we're looking for an increase. The average inflation-adjusted claims value for all claims ever paid by the company has been $2,500. Alright, so we're talking about an average for everything that's ever been done. So that's the entire population of claims for the company. So that $2,500 is our population mean, or our mu. So let's write that dude down. So obviously we're dealing with a test of means. So we have a average, and it is $2,500. Alright, so let's keep reading. With a standard deviation of $600. Okay, this 600 is pertaining to the population. That means it is sigma. It is $600. Alright, the manager wishes to see if the claim's value has increased. So again, this is our claim. We are testing for an increase. Remember, it is a study. Remember, we can only ask data 3 questions. Bigger than, smaller than, or different from average. So we're looking for something that's bigger than the average. Alright, over the past year, in a sample of 200 recent claims was retrieved and yielded an average claim value of $2,800. So we have a sample, which is our N, remember. That's going to be our sample size. It's 200, so N is equal to 200. And we keep reading through here. It yielded an average claim value of 2,800. So our X bar, or our sample mean, is going to be equal to $2,800. Alrighty, so now we have all of our information that we need to answer our problem. Next thing we have to do is figure out what kind of test we're going to run. So let's go through our decision tree we talked about in class and figure out which type of test we're going to run in this situation. So if we recall, the first thing we have to look for is whether or not we have a test of means or proportions. Obviously we have a population mean and a sample mean right here. So this is a test of means. So this means we can either do a z-test or a t-test. So let's look and see what the answer to our second question is, since we're dealing with means. Do we have a sigma? The answer to that question is yes. So we can still either run a z or a t-test. Now we gotta go through our third question. And what is our sample size? And our sample size is 200, which is bigger than 30. So we are going to run a z-test. Run a z-test. So let's write down that formula right quick. Z is equal to X bar minus mu divided by our sigma over the square root of n. Alright, so now that we know which test we're going to run, I actually skipped a little bit ahead. So let's back up now and let's figure out what our hypothesis is. Okay? So let's get our hypothesis. We're doing a hypothesis test, so this is kind of important. We have a null hypothesis, have an alternative. We know our hypothesis deals with means. So let's figure it out. So what the manager is looking for, we're going to be testing to see if there is an increase, and that is our claim. There is an increase, and this is a study, so it's going to be a research hypothesis. We know what mu is right there. It's $2,500. We know it's a tested mean, so our hypothesis always looks like this. Mu is equal to some number. In this case, it's $2,500. Alright, so let's look at the claim. Claim is has the value increased. So remember our three questions: bigger, smaller, or different from. In this case, we won't know if the new value is bigger. It's a research study, so our claim is going to go in the bottom. So bigger than $2,500 in our alternative hypothesis. And for the null, we're going to have less than or equal to, because it's the opposite of our alternative. Alrighty, everyone. So we've already gotten all of our relevant information to solve the problem. We know what our hypothesis is, and we know we're going to run a z-test with means. So our next big step here is to figure out what is our test statistic. So let's go ahead and solve for that test statistic. We're running out of room on the other page, so I'm going to hit scroll down for us. So remember, we're running a z-test, and our formula for that is x bar minus mu divided by sigma over the square root of n. Let's plug in all of our relevant info. We're going to have 2,800 minus 2,500 divided by 600 over the square root of 200. So now all we got to do is solve it. So we're going to have 300 divided by 600 over the square root of 200. Alright, so let's go ahead and get the square root of 200. Okay, so we're going to wind up with 14.1421. So, remember, like I told you in class, we're always going to round off when we're working inside of a problem to 4 decimal places. So round that off to 4 decimal places. $14.1421. So let's keep working it out. We'll take 600 divided by 14.1421. It's going to give us 42.42651. So we'll round that to 42.4265. Alright, just a little bit more math. 300 divided by 42.4265. It's going to give us a test statistic of 7.071. 7.071. Remember, we always round this one off to 2 decimal places. So our z statistic is equal to 7.07. That's a pretty big number, and when we get test stats this big, you can be almost certain every time that we will always reject our null hypothesis. Okay, the probability of making a type 1 error with a test stat this big is next to nothing. Whenever we're 6 standard deviations away from the mean, there's a 3.4 in 1 million chance of making a type 1 error. So when we're 7, that's even going to be even greater than that. So when we run into a test stat this big, you're always going to reject the null hypothesis. The p-value is going to be very, very small. You're not even going to find it on any of our tables. And when you compare it to any critical value, normally we're comparing them to a critical value of like 1.645 or 1.96. It doesn't even compare. So this is always going to give you a situation where you will reject the null hypothesis. We're 7 standard deviations away from the mean. So let's put a little curve up here. Here's our mean. There's 1 standard deviation away. That's 68% of all of our data. There's 2, that's 95. There's 3, that's going to be 99% of all of our data. So there's 4, there's 5, there's 6, and there's 7. You're way down here in this tail, and the probability of making a type 1 error is next to nothing. Like I said, 6 standard deviations is 3 in a million chance of making an error. 7, it's probably going to be like 3 in 10 million. So whenever you see a test stat this big, reject the null hypothesis. Alrighty, so far we've went ahead, we've read our problem, we've gotten our type of test, we've done our hypothesis, we know our test statistic, we saw that our test statistic was really big, and we know that we're supposed to reject our null hypothesis. To the average person, that means absolutely nothing. So now we're going to step ahead to our last step in our hypothesis testing, and we're going to go ahead and make our English conclusion. Okay, so let's do that. Let's write our English conclusion for this problem. I went ahead and I copied our problem again down here, and I wrote down our hypothesis so we can do that. So we know that our statistical conclusion was to reject the null. But what does that mean? So if you recall from reading the problem, we're testing the claim that the values increase. The claim value has gone up. Alright, so our null hypothesis was, because remember this was a study, that the value has not gone up. And our alternative is that the value has increased. So remember, we rejected this. We said, nope, there is no way that this can be true. Or next to no way. There's only like a 1 in 10 million chance this is right. So we rejected it. Said, nope, that's not the case. So when we reject our null hypothesis, we're going with the alternative. So there's a pretty good shot that the value has indeed increased. And that's all we're going to write. So for our English conclusion, it appears the value of the claims has increased. So it appears that the value of the claims has increased. So what does that mean? What does our manager here for this insurance company need to do? So if the value of the claims has increased, based on this study, the insurance company manager is most likely going to need to raise rates, okay? She needs to raise rates to keep our company solvent. So, this is how we're going to be using these hypothesis tests to make recommendations to managers. This is what you're going to be doing in the field. You're going to be looking to see if there is statistical validity behind a recommendation. And in this case, you know just about without a shadow of a doubt that these claim values have gone up. And if you want your company to keep making money and not go broke, then you're going to have to do something about it. So I hope you kind of understand how this process works. I'm going to put some more videos up that we're actually going to go through the table and get a p-value. Look for more videos to come out. If you have any questions, do send me an email at zmoore@ulm.edu, and I'll see you guys in class.